So hello everyone, my science fair project is about homopolar motor. So let's see. So, a homopolar motor is a direct current electric motor with two magnetic poles, the conductors of which always cut unidirectional lines of magnetic flux by rotating a conductor around a fixed axis, so that the conductor is at right angles to a static magnetic field. The resulting EMF or electromotive force being continuous in one direction. So you guys might be wondering why I choose homopolar motor as my science fair project when my topic is about magnetism. Do these two are connected? Well, yes. As you can observe in my experiment, you can see a conductor wire, battery, and a magnet. Well, obviously, battery and conductor wire are for electricity, and magnet are for magnetism. So, we can say that electricity and magnetism makes homopolar motor. But what is the relationship between electricity and magnetism? Why does it make homopolar motor possible? So, electricity and magnetism are two related phenomena produced by the electromagnetic force. Together, they form electromagnetism. A moving electric charge generates a magnetic field. A magnetic field induces electric charge movement, producing an electric current. An electromagnetic wave, the electric field and magnetic field are perpendicular to one another. Except for behavior due to the force of gravity, nearly every occurrence in daily life stems from the electromagnetic force. It is responsible for the interactions between atoms in the flow between matter and energy. Since electricity and magnetism are incredibly important, it is a good idea to begin with a basic understanding of what they are and how they work. So that's what makes homopolar motor possible. Now, thanks to a common battery, a thin wire, in a magnet, we are able to explain the working principle of electric motors, showing the Lorentz force principle. When we talk about Lorentz force, we talk about the combination of electric and magnetic force on a point charge due to electric magnetic fields. This simple experiment allows us to a better understanding the Lorentz force. For this project, we need a thin wire, a battery, and a magnet. For this project, we will use this battery and this magnet. We are using a thin wire because it's a good conductor for electricity, but most of all because it is not a ferromagnetic material, which means does not turn into a magnet when electricity flows into it, avoiding any magnetic field interference. Okay, this is a shape that the wire must turn into. We simply place the shaped wire on the top of the battery, keeping in mind the wire terminals must be in touch with the magnet. So our wire starts to rotate. That's because our thin wire is immersed in a magnetic field while the electricity flows into it, and a force acts on it, letting the rotation happen. This force is perpendicular to the motion of the charged particles.